Section 2013 is just a refresher on the spectroscopy of carbonyl compounds, of aldehydes and ketones specifically. And so there's just a couple of things that we're going to look at with the spectra, starting with the IR spectra. You guys already know with any carbonyl compound, anytime we have a carbon-oxygen double bond, we're going to see a nice identifying peak around 1700, and this one's a pretty sharp one. Normally they're not sharp like that. Also for aldehydes, only aldehydes, we're going to see two peaks in this area around 27 and 2800. And this again is just for aldehydes. It's for the hydrogen that's attached to the carbonyl group. And in class we talked about how these peaks a lot of times can be kind of hard to see. They can get hidden with normal carbon-hydrogen stretching. A lot of times they're not very strong. So it's more of a confirmation thing, like I think I might have an aldehyde. I'm going to go look for the aldehyde peaks in the 27 and 2800 area. So a lot of times it's not easy to just see them. And so there's that. For, I don't want to do this one. For proton NMR, the only thing to point out here, again, with the aldehyde, the hydrogen that's on the carbonyl group is extremely deshielded, and you can see it's showing up way out here at about 10. It could be anywhere from 10 to 12 parts per million. So it's going to be super shifted very far to the left, and that makes it easy to identify. And there isn't anything like that for ketones, because ketones don't have hydrogens on their carbonyl group. And then also, last but not least, we're going to look at the carbon NMR. This is carbon NMR. And for carbon NMR, what we see here is pretty similar. It kind of parallels the location of the hydrogen of an aldehyde in the proton NMR. So when we're in the carbon NMR, the carbonyl carbon is going to show up way super shifted to the left. This is going to be for both aldehydes and ketones.